Let's do question number 2 together. Consider function y equal to fx, and you are given the graph of y equal to fx, where point A and point C, according to the question, those are the x-intercepts. Point B is a local minimum. It's also a stationary point. And point C is a non-stationary inflection. Point D is just a point on a graph. And we have a horizontal asymptote y equal to k, which means that as x approaches to positive infinity, y equal to fx approaches to k. Now, we are given a table, and we need to determine the sign positive, negative, or 0 at the point B, C, and D for fx, f dash x, and f double dash x. So to determine the sign of fx, we take a look at the point on the graph. If we are given the graph of y equal to fx, then fx is just the y coordinates of the point. So if the point is below the x-axis, indicating that the y coordinates is negative, and if the point is above the x-axis, indicating that the point is y coordinates is positive. So take a look. FB, point B is below the x-axis, so FB is negative. Point C is the x-intercept, so FC is equal to 0, or the y-coordinates of point C is 0. Point D is on a graph, but it is above the x-axis, so FD, y-coordinates of D is positive. Now, how can you determine the side of the first derivative? So first derivative is the gradient or slope function. You will take a look at the graph at which interval the graph is increasing, indicating that the slope or the gradient of the tangent on that interval is positive. And if the graph is going down from left to right, which means decreasing, then the derivative is negative. So let's review a little bit about the concept. Let's say I have, this is y equal to fx, and this is x equal to a is a local maximum. And you can see when x is less than a, the function is increasing. And if you draw any tangent on the increasing interval, the tangent is going up, indicating that the slope gradient of the tangent on the increasing interval is positive. So f dash x is greater or equal than 0 when x is less than a. And on the red part, when x is more than a, the function is decreasing, going down from left to right. If you draw any tangent on the decreasing interval, the tangent is going down, indicating that the slope or the gradient is negative. F dash x is less than 0, less than or equal than 0, when x more than or equal a. So take a look at this. F dash B. Point B is a local minimum. It's a stationary point. So if you draw a tangent at B, the tangent is horizontal, and f dash x is a gradient of the tangent. So if the tangent is horizontal, the slope is equal to 0, which means f dash B is equal to 0. So I would write 0 here. At point C, when x is more than b, the function is increasing, indicating that f dash c would be positive because it's on increasing interval. And also point D is on increasing interval, so f dash d is positive. To determine the side for the second derivative, you will take a look at the shape of the graph y equal to fx. So let's review a little bit about the second derivative. This is called concave downwards. So if the graph is concave downwards on an interval s, then the second derivative f double dash x would be less than or equal than 0 for all x belong to that interval. and this is concave upwards. So if the graph is concave upwards on an S interval, then the second derivative f double dash x would be larger or equal than 0 for all x belong to that concave upwards interval. So we take a look at the y equal to fx graph. X equal to c is a non-stationary inflection. So f double dash b, b is belong to the concave upwards interval. So f double dash b would be positive. C is an inflection point. And remember, the second derivative is equal to 0 at the inflection point. So f double dash c is 0. And f double dash d, when x is more than c, the graph is concave downwards. So this is concave downward. So f double dash b d would be negative. Let's review a little bit about inflection points. How many types of inflection points? There are two types, stationary inflection and non-stationary inflection. What is a stationary inflection look like? It looks like this. Let's say this is x equal to a. These are stationary inflection. We call it stationary because when we draw a tangent at x equal to a, stationary point is where the tangent is horizontal at that point. The tangent is horizontal as x equal to a, so we call it stationary point. At the stationary point, the tangent is horizontal, which means the first derivative, f dash a, is equal to 0. We call it inflection because as x equal to a, the graph changed from concave downwards to concave upwards, or vice versa. So the second derivative also equal to 0 at the stationary inflection. At inflection point, second derivative equal to 0. Another type of inflection point is non-stationary inflection. It looked like this. Let's say this is x equal to b. These are non-stationary inflection. This is because non-stationary because when we draw a tangent as x equal to b, it's not horizontal. So the first derivative not equal to 0 as x equal to b. So f dash b is different from 0. However, at point B, the graph changed from concave downwards to concave upwards, or vice versa. So the second derivative would be equal as x equal to b. So f double dash b is equal to 0. So remember, at inflection point, the second derivative is equal to 0. Now let's move to question 2b. You are asked to sketch the graph of the first derivative. So let me take a picture of the original graph and put it on the left so we can see it easily. All right, it's here. So to sketch the graph of the first derivative, you need a side diagram of first derivative and second derivative. So let's draw the first derivative side diagram. On the first derivative side diagram, you would put the point where the first derivative is equal to 0. Those are stationary points. So according to the question, there's only one stationary point, which is x equal to b, a local minimum. So please put local minimum x equal to b on the first derivative side diagram. Now, let's determine the side. To determine the side of the first derivative, take a look at the graph y equal to fx when x is less than b. The graph is decreasing, so it's a negative. And when x is more than b, the graph is increasing, so it's a positive. How can we draw the side diagram of the second derivative? On the second derivative side diagram, we put the inflection point, the point where the second derivative is equal to 0. So in this question, point C is an inflection point. So please put x equal to C on the second derivative. And is it better that you draw the first and align with the second derivative? So x equal to C is more than x equal to B. You draw C to the right of B. To determine the side of the second derivative, you take a look at the shape. When x is less than c, the graph is concave upwards, so it's going to be a positive here. And when x is more than c, the graph is concave downwards, so it's going to be a negative. Now we're going to use the information of the first and the second derivative side diagram to sketch the graph of the first derivative. The first derivative side diagram, it will let us know which part of the f dash x graph will be below or above the x-axis. So here, the graph f dash x would be below the x-axis. And the graph f dash x has the x-intercept as x equal to b. And when it's go through x equal to b, it's above the x-axis. The second derivative side diagram will let us know the shape of the first derivative graph. So it's up and down, which means the first derivative graph will have a local maximum as x equal to c. So now let's combine all the information together to sketch the graph. So at first, the graph y equal to f dash x is below the x-axis, and then it crosses the x-axis as x equal to b, and then it's go above. It reaches maximum as x equal to c. And you can see that according to the f dash x side diagram, when x is more than b, the graph is the f dash x is positive, indicating that the graph f dash x would be above the x-axis when x is more than b. So you cannot, from here, you cannot continue drawing that it crosses the x-axis. It's not going to cross the x-axis because it's positive, it's above the x-axis. But if you take a look at the graph of the original, after x equal to b, look at when x approaches to positive infinity, the graph getting flatter and flatter, which means that the tangent is getting more and more horizontal as x approaches to positive infinity. If the tangent is getting more horizontal, it approaches to 0. So the function y equal to f dash x would approaches to 0 as x approaches to positive infinity. It's not going to crosses the x-axis. So this is the graph y equal to f dash x. And we are done with question number 2.